Think back to your junior year of high school. Between listening to the physics instructor's monotonous voice and fighting the pangs of drowsiness, you might recall something about subatomic particles. We know that all matter at a microscopic level is composed of atoms. But did you know that atoms are not the smallest particles that exist? An atom is made up of neutrons, protons, and electrons, known as subatomic particles. If you're a fan of the popular sitcom The Big Bang Theory, then you've probably heard the term particle accelerator a lot. A particle accelerator is a machine that does exactly what it sounds like. It accelerates particles. It accelerates elementary particles such as electrons and protons to extremely high speeds, several times faster than the speed of light even. This produces beams of charged particles, which can then be used in many experiments. The world's largest and strongest particle accelerator is known as the LHC, or the Large Hadron Collider. It was built at the European Organization for Nuclear Research, also known as CERN, which is a name you might have heard frequently if you're interested in physics. Established in 1954, CERN is the world's first particle physics laboratory and home to the LHC. A collider is a specific type of particle accelerator that smashes two particle beams coming from opposite directions together. It does this using the 27-kilometer ring of superconducting magnets, with many accelerating structures it's comprised of. And the LHC is nearly 200 meters deep beneath the France-Switzerland border, near Geneva. It's actually the biggest machine to have ever been made by humans. You might be thinking, okay, so it's some big machine deep underground. What's the point? Well, the LHC is used for experiments simulating conditions and circumstances that would otherwise not be possible on Earth. Colliders, though hard to construct, are extremely vital for research due to the fact that they can reach an incredibly high center of mass energy. Particles, usually protons, extracted from the hydrogen nucleus are crashed into one another with such force that they end up creating new particles. Unfortunately, these new particles are incredibly short-lived and decay in fractions of a second. During this time, scientists need to figure out what these particles are. By analyzing these particles and the byproducts of the collisions performed at the LHC, scientists are able to learn more about the structure of the subatomic world and the laws of the nature they follow. These experiments can, to a very tiny microscopic scale, even simulate the Big Bang, which can then provide valuable insight into the creation and origins of the universe we live in. The results of the experiments performed at LHC also help advance research in the fields of medicine and the environment. One very major breakthrough made by the Large Hadron Collider was in 2012, when the Higgs boson was first discovered. This is also known as the God particle because it is said to have been the substance that created the Big Bang, subsequently resulting in the universe as we know it. The Higgs boson is what joins all particles that exist in the universe together and gives all things in the world their matter. Despite being a superhuman machine that can do things physicists did not think possible a few decades ago, there's no need for other people to worry. It's not going to fry the Earth or create the world's deadliest bomb by accident. Even if a black hole is made, it's going to be extremely tiny and disappear in an instant. If you found this video insightful, don't forget to let me know by leaving a comment. Also, do share this video with your friends on social media. See you in my next one.